Okay, students, we're going to multiply matrices now. When I multiply matrices, I need to check first off to see if I can multiply matrices, which means I have to identify the dimensions of each matrix. This is a 2 by 2. Convert 2 rows by 2 columns. You do rows first. It's always rows by columns. COL for columns. And this is a 2 by 2 also. If the two inner numbers are the same, you can multiply them. So you have to first check that. The final matrix size will be the two outer numbers. So the final matrix size of this will be a 2 by 2. Those do not have to be the same. They can be different. In order to multiply matrices, the two inner numbers must be the same. Remember, it goes rows by columns every time, rows by columns. So that's how you determine whether you can even multiply matrices first. Now, if they're the exact same size matrix, 2 by 2, 3 by 3, of course you're going to multiply them, okay? The question is when they aren't, can you check your inner numbers, okay? So, now, what do? The first one, first matrix, you circle your rows. The second matrix, you circle your columns, okay? So, I take the first row and multiply by the first column of the second one, and that gives me spot 1, 1. To find spot 1, 2, row 1, column 2, I take the first row by the second column. That's why it says AF plus BH. To find the second row and first column, I take this second row and the first column. That's why I say C times E plus D times G. And to find spot element 2, 2, I take the second row by the second column. That's why I say CF plus DH. Okay, so that's how you can know which ones. If I can identify the element correctly, then I do that. So like I said, since this is element row 1, column 2, I take row 1 with column 2, and that gives me that spot. And I do the first times the first, that's the AF, plus, it's always plus as you see in between there, the second times the second, B times H. Okay, so that's how you know which combination to put together here. Okay, now notice on this one, these are not square matrices. This is 3 rows by 2 columns, and this is 2 rows by 2 columns. I can multiply them together because the inner numbers are the same. The final matrix size will be a 3 by 2. Final matrix. Final matrix will be a 3 by 2. So if I wanted to, I'll put in the final one. I have 3 rows and 2 columns. So I know I'm going to have a number in each of those spots when I'm done. Final matrix size is a 3 by 2. Okay, it's the outer numbers. So again, this is spot 1, 1. So it says to take the first row and multiply by the first column. Put those together. So I have negative 20 and a negative 3. Negative 23. And there you see that right there. This spot right here is a row 1, column 2. So I take row 1 and put it together with column 2 of the second one. Negative 4 times negative 2 is 8, plus 9 is 17. And that's why you see 17 there. Okay, this spot right here is element 2, 1, row 2, column 1. So I take row 2 with column 1. So 10 plus 2 is 12. And that's why you see the 12 right there. This spot right here is a 2, 2, row 2, column 2. So I take row 2 and switch it to column 2. Negative 4 and negative 6 is negative 10. And that's why you see negative 10 there. This spot right here is 3, 1, row 3, column 1. So I take row 3 and column 1. 5 minus 7 is negative 2. So I see negative 2 there. And lastly, this is spot 3, 2, row 3, column 2. So take row 3 and put it together with column 2 now. Negative 2 and positive 21 is 19. And that's why you see a 19 there. Okay, and so here's their work writing it out right there that I just did in my head when I told you what I did. Okay, that's writing out the steps of what you're multiplying and adding together to get that final answer. All right, so this is how you multiply matrices. Okay, so they give you 9 to go ahead and do there. The back side over here now, what it is doing is talking about the commutative properties of multiplication. Says the commutative property of multiplication does not hold for matrices. So that means you can't switch the order of the matrix. 2 times 3, if I just do 2 times 3, that's 6. That's the same thing as 3 times 2. But in multiply matrices, that does not work. Matrix A times B does not equal. So that's saying matrix A times matrix B does not equal matrix B times matrix A. That's commutative property. That is not true for multiplication of matrices. Okay, so here they've given you your properties again from Algebra 1, and they're wanting you to do the calculations on each of these. So this would say first add matrices A and B together, and that stays on the left side, whatever that answer is, and then multiply it by matrix C. So they added these together. When you add them, remember you just add the same spots. 4 plus 2 is 6. Negative 3 plus 0 is negative 3. 2 plus 5 is 7. And 1 plus negative 3 is negative 2. So there's my A plus B right there. That was A plus B. Now leave that on the left side, as it is here, and multiply it by matrix C right there. And remember, it's rows by columns, rows by columns. They're showing you work there, and there's my final answer right there. Okay, here you're multiplying matrix A times C, get that answer. Multiply matrix B times C, get that answer, and then add them together afterwards. Okay. And it says, note that although the results in the example illustrate the right distributive property, they do not prove it. Okay, remember I take some number out front by the multiplied by the matrix, that's called scalar multiplication. So it says scalar C, negative 4. Little c is negative 4. So if you see little c here, that's a negative 4, you'll multiply each of the coordinates inside by negative 4. So you first multiply matrix A times B, get that answer, and then multiply all the coordinates by negative 4. This one says multiply negative 4 times the coordinates of matrix A, get that answer, leave it on the left side, and then multiply it by matrix A. And so you're going to check to see if these are true or not. Okay, that's your question. So here, this would be to prove that when I do commutative property multiplication matrices, it will not be the same as they've already told you. Okay, so what you're doing on this side is determining whether these properties that are normally true for most algebra stuff, algebra 1 stuff, if they're true for matrices. That's what you're testing down here on this side. And so you're also practicing multiplying matrices, adding matrices, putting all your combinations together here. That will do it.